Welcome back, everyone. Let's talk about your exam, not the question, but the environment. I want to give you opportunity to review that during the weekend, early next week. So the proctoring of the exam. Hopefully, most of you are familiar with this software. It's the software that we're going to use for proctoring your exam. As I mentioned before, your exam is going to be on Canvas, it's online, we are not in the classroom. So basically, for your exam, in a week, what I am asking you to do is, we do not have a lecture. You do not need to connect to Zoom that particular day. That day, you go and access on Canvas your exam, and as soon as you finish your exam, you are done. The full lecture that day is for your exam. So for the exam, you're going to access Canvas. The exam is online, as we mentioned, but you need to have this software. Question, have you used the software before? Yes, no. Okay, I think, okay. I am pretty sure that most of you in the past year used this software for one or more exams. Now it's almost the standard. So once again, just to be sure that you remember the process, and just in case that someone do not know what I am talking about with this lockdown browser. Number one, you're going to have this link at the end of the lecture. So 5:45, probably the link is going to be there on Canvas. Sample exam, and you need the software. If this is the first time that you use the software, what is going to happen is you click there and you're going to receive a screen with some kind of message like that one. So you're going to have the opportunity to get the software. The software is a browser, so you get the software installed in your computers, and then you use to access Canvas and do your exam. Next week, you're going to have this link in the meantime. Similar, it's going to have all this legend about you need the lockdown browser. When you open your exam, you are going to need to follow a process that by now should be familiar, a window like this. You need a camera. Probably that is the most important thing that I need to be sure that all of you know or remember. In order to do your exam, you need a webcam. Usually you do not enable the webcam. I have a few people here that show me your faces. So hopefully everyone else, the other 50, 60 people connected, that day for the exam, you need the webcam, you need to enable the webcam. If you do not have the webcam, if you do not allow the software to use your webcam, you are not going to be able to continue with the exam. So either if you do not have one, if your webcam is not working, whatever, I think you can ask for one in the library or in the Fulton School. There are, I think we are borrowing cameras to the students if they do not have one. So you have 1 week to do your research, and either in the school or with your friends to be sure that for the exam you have a computer with a camera. With that, having the webcam, you're going to have this window. The software theoretically do not allow you to open any other thing, so you do not have access to any other web page or the videos or the material, the slides, whatever. You should not use them. The exam is closed book. So if not because the software do not allow you, it's because they are not allowed during the exam. So closed book, nothing that you can use. The only thing that I am okay with you using is scratch paper. Some people ask me, I need to have paper, I need to write things and think, writing. You can use a scratch paper. The only thing, please, two things. Number one, be sure that the paper is empty. Do not use recycled paper. If the paper has something printed or you write something there before, probably the video, the software is going to flag your exam as suspicious. Help us, empty paper, white paper. And two, when you start your exam, you are going to be asked to do an environment check. During your environment check, you show your room, particularly your desk. Please be sure to show also your paper. Show the camera that your paper is empty, and you're going to have that in your desktop during the exam. You will need an ID with a picture. My recommendation, your ASU ID, some people have this ID connected with a bank account. As usual, the recommendation, you can cover the numbers that correspond to anything that you do not want to be online. So an ID, the only thing that we need, your full name and your picture. Basically, we're going to compare that with the image on the video and your full name in the roster. So any ID that you have, a driver license, if for any reason you do not have the ASU ID or a passport, I don't know, something with your picture and your name, and you can cover any information that is not related with identifying you, name and picture, including bank accounts. So you will need to do that. Camera is open. The system is going to take a picture. It's going to ask you to show your ID. It's going to ask you for the environment. It's going to record that. Then you're going to be able to start your exam. Something that some student mentioned to me, when you run your exam, you're going to have the browser. In the browser, you have the question and multiple choice and open. It doesn't matter. Usually you have here the multiple choice or whatever. One question per screen, and you can move back and forward through your questions. You are being recorded, the video, but also your activities on the system. There is a log regarding how many time you spend in one question, if you answer and go back and change your answer. All that activity, as you can imagine, computer science, software engineering, you know that all of that is recorded. So we have the information about what you do with the exam. Please be aware of that. Anyway, this is your screen, and I think in the corner, you have this option to submit your exam, to I am done, click. So some students mention that you click there and the system do not ask you, are you sure that you want to submit? Some people mention that. I do not know if that is true or not, but please, something that I want you to recommend. This is your screen. Be very careful with your mouse, and whatever you do not click this guy until you are done. I cannot reopen the exam for you. If you click submit, is submit. It's not like we are in the classroom and I can give the exam to you back. That is not the case. Your questions are randomly selected from a pool. So it's not like I can reopen the exam for you if you send me an email. That cannot happen. So be very careful with that guy, the submit. I don't think so. Two-factor authentication in Canvas, no, that is nothing related with the exam. I don't think that you are going to be flagged for that. The camera turned on, exactly. Be careful with, something that I am doing, going back here. If you have the software, if you have this installed, or if you install and then go back, please, this one is an exam that you can take having the software. If you do not have the software, again, you're going to be redirected to the link to get the software. But once you have the software, please take the sample exam. This sample exam, number one, is 0 points. So don't worry, you can take that one as many times as you want. It's not going to impact in your grade in any way. It's going to be open by the end of the lecture, and I am giving you 1 week with that guy there. The only reason is there is a question here, only one question, and I think the question is, how are you? Or something like that. But you can use that one, number one, to test your system, to review that your camera is working, your computer is working, you have the software and so on. And number two, to get familiar with the user interface, to be sure in which position is this submit option, and to check everything that you need to check. The size of the screen in your desktop, or if your phone is going to work, or your tablet. Review the sample exam and check that your system, whatever it is, works. Good? Okay. Again, you do not receive points for the question, so I do not remember which one is the question, but if it's something like, how are you? And probably both options are correct or both options are incorrect. I do not remember, but the only goal is for you to familiarize with the interface. That's it. So clear, guys, the proctoring software. Any question regarding this? 1 week for you to install the software, 1 week for you to at least take the sample exam to test your systems and familiarize with the interface. Another thing that I am giving to you is posted on Canvas also, is this document. It's the same document that I shared with you in 360, so some of you could be already familiar, but those are the rules for online exams. They are not mine. The document comes from the Fulton School. So just like they give us the document, I am sharing the document with you, is all the things that you can or cannot do during the exam. Important things, please, you cannot use any headphones. You cannot listen music or anything that covers your ears. The software is going to think that you are kind of in communication with someone else that could be sharing with you the answer or something like that. I do not know. But the rule is you cannot use earphones during the exam. Sorry, guys, but it's just 1 hour. You cannot cover your face or your head, and you need to show almost everything in your room, a 360 video of the place in which you are going to take the exam, something like that. So you have 1 week to figure out where you are going to take the exam and how, desktop, laptop, tablet, phone, whatever. Figure out that. Use the sample exam to check what is the environment. Something very, very important that I want you to remember. You are being recorded. Your face, it's very easy to be aware that your face is being recorded, but some people forget that also the audio is being recorded. So if for any reason you like to talk aloud during the exam, please do not do that. You are going to be flagged because the system is going to think that you are talking with someone else in the room. But the second option is sometimes people start talking about the exam and sometimes about the TAs and even the instructor, and whatever you say is recorded there. So you do not want to be recorded speaking about, things. So be careful. Remember that you're being recorded, the video and the audio. Yeah, I am aware that several people like the music during the exam, and I have had this conversation several times. You cannot do that. Sorry, guys. Again, rules for the school. So 1 hour. Use 1 hour. Silence. No speaking. Not talking with anyone or with yourselves, and no music. Good. If you're on campus, you can take the exam almost in any place. I think you are even able to use the classroom and take the exam there, but you are going to use your computer. The exam for everyone is going to be on campus, so that is fine also. We are aware that if you go to the library or you are in a classroom or in some open space in the campus, there are going to be noise around. At the beginning of the exam, the system is going to ask you to show your spaces. So it's going to be kind of evident that you are in an open space. That could be okay. The only thing is, I don't know, put some kind of note in some place for the people to know that you are busy in an exam. So no one is going to approach you to just talk about whatever, right? So just be sure that whatever space you select is a space in which you can be quiet for 1 hour, something like that. There could be noises around, environmental noises. Hopefully that is fine. Yeah, very good question, both the water and the mask. There is only one time at the beginning of the exam in which I think the software is going to ask you, is going to tell you that the system is going to take a picture. Probably for the picture, you need to show your face, just like picture by. And after the picture, you can continue the exam with the mask. If you are in a place that requires the mask, that is fine. During the exam, no problem. The picture, I think in some moment, 1 second, the picture is going to be taken your face. Yeah. You can drink water, that is fine. Again, just follow the rules of the place in which you are. Some places do not allow you to have food or water, but if the place in which you are taking the exam is fine with food, water, and so on, there is no problem during the exam. Good. So my only recommendation, talking because we have had several cases in which the system is going to report to us that you are doing something wrong. And it's going to be kind of 1 week, 2 weeks in which we need to review your case. And during that time, we cannot post the grades of others. So if you're wondering why the grades haven't been released, it's because we're reviewing cases of some people that something happened. So help us avoid those kind of situations. Anyway, good. I am going to show you the questions, some examples of questions, both multiple choice and open, but in the next lecture. What I want to ask you to do as a homework right now is just check your systems. Remember, question in the exams, 2 types of questions. There are going to be open questions. The open questions are going to be mostly related with programming. So you need to be ready to start writing source code. Usually 1 method or a couple of lines, nothing long. The time is not going to be an issue. And multiple choice questions. And multiple choice questions about everything that we have reviewed. My recommendation for the weekend, for this week, review your quizzes. Any question that you have on the quizzes could be again in your exam because it's the same pool of questions. Something that you can do is review your quizzes. Either you answer correctly or not, review the correct answers. If you do not have access to the correct answer for any reason, if you do not know how to access the correct answers, contact the TAs. They can give you indications about what to do, but you should have access to the correct answer in your quizzes. Review that, so that could help you for your exam. I fully agree with that. Review the observer and the code. Yeah. Yeah, I already mentioned that one. Some questions from your quizzes could be again in the exam. That is true. And I could add, review the source code for the observer, and I will say for the decorator also. The source code for the patterns that we review, 100% sure that you're going to have a question about that in your exam, if not 2, the open questions, source code from the pattern. So review that, very, very important. Another question that usually people ask is how many questions? In general, you are going to have your exam with about 20 questions. This is an average. The exact number of questions is going to change depending on your exam. The questions are from a pool. In the pool, there are questions that have different values, 1 point, 2 points, 5 points, and so on. So basically, the system is going to take the number of questions that are needed in order to complete 100 points. For some of you, it's going to be 20, could be 19, 18, 17, 21, 22, depending on which questions are selected. Now, more or less 20. Your exam can be done in 60 minutes. That is my plan. However, you are going to have the full lecture, which means 75 minutes. My approach, my recommendation, what we did is we are considering that you are going to have full 60 minutes for the exam, and worst case scenario, you will need 15 minutes to do all the configuration that I showed you before. Connect to the Proctoring software, show your ID, do the scan of your room, enable, disable audio, camera, I don't know, whatever technical could happen, hopefully you can solve it in 15 minutes, so you have 60 for the exam. Obviously, if you can do this in 5 minutes, that is great. You have 70 total to do your exam. And if you have 60 and there are 20 questions, we are giving you kind of 3 minutes per question. For the multiple choice, most of them, you can answer in 1 minute. If you know the answer, it's kind of quickly. For the open ones, the ones that you need to write source code, hard to tell you, depending on how fast you write, but probably 5 minutes in the worst case scenario. In average, the people finish the exam in less than 30 minutes. Again, that is an average. I am not telling you that you need to finish in 30 minutes, but if you finish the exam very, very quickly, like 20 minutes, 30 minutes, 40 minutes, that is kind of normal. People usually do that. But you can stay there and use your 75 minutes and review everything. Is usually up to you. The time is not a problem. Again, review the lectures, review the material. You have time. It's all about you having the knowledge to answer correctly the questions there. Good? So, closed book, do not use anything. Scratch paper is okay. The exam only available during the lecture time. If for any reason you start late, if for any reason you start the exam at 5 or something, whatever happened that day, your exam is going to close that time automatically. So it's not like you have 75 minutes after you start. Is you have 75 minutes only if you start 4:30. The exam is going to close with whatever you have there, 4 and 5:45. So be aware of that. Put a reminder in your computer, watch, phone, whatever, that you have an exam that day and you need to start at this time. And again, we do not have a lecture that day. You do not need to connect to Zoom. Go directly to Canvas and do your exam, and you are done for the day regarding the class. Good. That's it. Questions? Okay, moving forward, talking about the decorator. The previous lecture, we talked about Observer. You are experts with observers. Yes, review the source code. We talked about the decorator. You are almost expert with the decorator. Review the source code. In the previous lecture, we review this example with the decorator using use text. The important things, the classes that you need, the important things, this and this connection. This one is the signature for the decorator, a class that inherit and also do aggregation from another class. These two relationships, if you saw that in a diagram, probably the decorator pattern. The other thing, this family in which you have several classes and all of them are connected with a common parent, usually that common parent and interface, but could be an after class. We reviewed this example with the core element and the decorations. We did this using a text-based approach in which the decoration were used additional text, something easy. The most important thing, one, you create an object, or you create an object and a decoration, and in some point, somehow, usually with this method add, you do the connection between the original object and the decoration. You can have the original object only, you can have the original object, and you can connect with different decorations. Original, decoration, decoration, connection, connection. That is in the main. In the classes, a parent for everything, the common one, the child's one that is going to be the core, the original one. The core, in this case, the message that we want always. The only thing that need to do is the implementation of the parent and the override of the method that we define in the parent. The other child, the brother of this one, is the important one. This one is the one that have the relationship of inheritance and also aggregation. This one is going to do the inheritance, but this one is going to have the variable that represents the diamond. And therefore, it's going to do the override of the method because of the inheritance, but also it's going to have this method add or set that is the one that is going to provide a value for the variable. The important one. The others, the childs of this one, the decorators, they are going to do the inheritance. They need to call the super and then do whatever they want. Another child, the inheritance, calling the super, do whatever they want. That is the template for the decoration. Something that I asked you to review, something that we need to check just to close this is, well, that was with text showing messages. What if I want to do the same, but using graphical elements? Graphical elements, it just increase the behavior in the decorations and also in the original guide. Adding graphical user interfaces with a decorator pattern. Well, example. What if I want to do exactly the same that I had before, but instead of showing you the message, I want to show also pictures. And now that I am showing pictures, I am going to include here probably panels and frames and widgets. We have worked before with graphical elements. We know how to work with graphical elements. The only thing that I need to do is to put the graphical elements, work with the pattern, and do some kind of connection. And I can achieve something like this. What do I want? Real time, remember? This is all about decoration, and the decoration can happen in real time. And if this can happen in real time, something that I could have is options like click here, or click here, or click here, or here. And what I am going to do, depending on which of the buttons I click, is to create an object with or without decorations. I would like to click here, and I would like to create an object and just have that object, maybe this one, alone. I want to click here, and probably I want to have the object and also one of the decorations. Or I want to click here and have the object with the other decoration, or I want to click here and have the object with both decorations. A graphical user interface, and just for fun, I click, and depending on what I click is the order that I sent regarding what do I want, an object alone or an object with one or more decorations. I am pretty sure that you can figure out the solution here quickly. Source code and class diagram, always. Source code, the class diagram, they should match. Number one, if you imagine the class diagram, I am sure that you are going to agree with me, like, well, we need two things. This looks like the decorator pattern, so probably you are going to have something in the class diagram that looks like the decorator pattern. The class is in yellow. Did you notice different names, but the shape is the same? A common parent, two childs, two decorators. That is what I need. And between the childs, this relationship, inheritance and aggregation, two relationships in one part. That is the yellow boxes, the decorator pattern. Okay, decorator. To be more specific, if I have a decorator pattern, you remember this guy here, that class is the one to represent the element without decorations. That class somehow should be the one responsible of creating this picture, of doing that particular element. If I think about the decorators, I have two. And what they are going to do is this part and this part. The party celebration thing with the message and the orange balloon with the message. What I can do later is to put together the core guy with the two decorations, or I can put one with the two, whatever. That is what I want to do. Decorations, original ones. Now, moreover, I am doing this as a graphic interface. So I need an application. I need a class to put my main. Important thing, you do not put the main in any of the classes of the patterns. The patterns are like the building blocks in a Lego thing. The patterns are not the system itself. The pattern should not host the main of the project. The patterns, like these yellow boxes, are part of the project. They are going to solve a particular problem in the project, but your project, your main, your application, that class is a different one. You notice that in the text-based approach, it's the same for the graphics. I have a class, that class is going to be called main, just because it's the name that my IDE gives to the class, and there I have the main. By now you know that if I want to do a graphical user interface, this class main, a very good idea is this one is going to be inheriting from JFrame. You know that. Moreover, that one probably is going to be using did you notice that in the interface I put all of this? This one, the frame, is going to be using those. And hopefully you remember that they can be local variables. You can create the variables JBottom in the constructor. And because they are going to be local variables, then the relationship is not anything with diamonds, but just the association between the classes. And in particular, that the arrow should be out from the main and point to the thing that you are using. So, and if you want to be more specific, you are using 4. You can put 4 lines, or you can put a number. It works. Now, the other thing that you are using, and here, you can put the panel global, and then a diamond here, or you can put the panel local, and therefore remove the diamond. Up to you. Both solutions are possible. Just because I am thinking right now that I am going to use listeners, probably, maybe, I will need this panel to have access to the panel, both in the constructor and in some other method. So if I am going to need something in more than one method, I need a global variable. Because if I put local, it's just accessible in the local context. So I do not know what is going to happen. Worst case scenario, it's going to be global. Worst case scenario, this panel, the panel that is going to have everything, is going to need aggregation. I just mentioned that this guy is going to be a panel, so that one. Moreover, I just mentioned that we are going to be working with listeners. And action listener is an interface, so something that you're going to have. And you can notice we're completing the class diagram, and everything in blue, or the things that I am drawing with the red pen, all of that is the graphical user interface, graphical things. The pattern in yellow, nothing happened yet. When I have all the graphical user interface, the only thing that I need to do is to think about how to connect this panel with the pattern. And could you agree with me that if I connect my panel with the parent of the full hierarchy of decorations and items, that solves my problem? Because what I want is to put inside of the panel this guy alone or that guy with something else. And that guy is a child of the top class. I could have here a connection with this class, or I could have here a connection with this class, or I could have here a connection with that class. Any of these three at the top could be the ones that I use. Just to play safe, connect with the parent, and you can use the full family. If I can do a program that follows this class diagram, I can solve the problem that I showed you before. In the diagram, hopefully you agree with me, and I just delete the panels and the inheritance and the J-bottoms. But in the diagram, looks like pretty simple. The number of connections is small. The diagram do not look like everything is connected with everything crazy. It's just, okay, two more classes with a few connections. If the diagram looks clean, probably the software, the source code is going to be clean also. So let's check the source code. Number one, we can start with the main. We can start with this one. And I am going to show you the diagram in the corner just as a reference. But we can start with that one, the main. What are we going to do in the main? I think by now you are familiar with the things. Number one, the class main, extend the frame, implement the listener. Just like we mentioned before. What should I do with the lines that I highlight there? If you notice, CompanionPanel and B1, B2, B3, B4, they are global variables. Can I move them to local? Or not? And the answer is, well, is everything about you need them in more than one method? Yes or no? If you are using them as a global, just remember in your diagram, you're going to need the diamond, at least the white. It is okay, but you need to have a reason. A reason, yes, like you need the variable in at least two methods. Because if you do not need them in two methods, they can be local to the method that is going to use them. Anyway, by now, they are global. By now, my particular diagram is using J-bottom like this, and my particular diagram, the connection with that class is with the diamond, because these are global. Just add the diamond. Okay, variables, the widgets and the panels. I have a constructor. In the constructor, what we do? Set up the interface, set layout to establish how we're going to put things together. Border layout, no big problem. Add the panel, add B1, B2, B3, B4. So basically I'm adding everything. Looks fine. I have an additional panel here, probably to put these elements. So all the bottoms are in the one panel. And then I add the panel with those elements, and I add the big panel that is my global variable. Just creating this thing similar to the one that I showed you. Panels, layouts, programming, basic things. Good, so nothing fancy here, nothing related with patterns or the solution of the problem, just graphics. Moving forward. What is this? Action perform. Is override. That is a method that you are adding because you implement the action listener, right? Just like happened with the observer pattern, you are implementing one particular interface and therefore you are committed to put a particular method. In this case, the action perform. This method, this is the method that is going to be called when you click in any of the widgets, the bottoms that we put, right? The method is going to be called every single time that I click in any of the elements. What we do? Well, we need to know which one was the one that was clicked. And I have two ways to know which one is the one that you click. You can compare the text inside of the element. So you can compare if the one that you click is the one that says standard, or is the one that says help or affect or whatever. You can use the string inside of the element and compare in an if the string, or you can compare the full object. In this particular example, the choice of the programmer is to compare the object. You receive a parameter. The parameter have the information of what happened, the event. Something that you can do with the event is to get the source of the event. The source of the event is the object that received the click in this case. And you just compare the object that received the event with V1, V2, V3, the names of the objects that you create, the names of the objects that have the listeners, and according with the element that you click, could happen this, or could happen this, or this, or this. Did you notice what is happening? Depending on which of the widgets you click, I am going to create one object, no decorations, or I am going to create one object and one decoration and connect them, or I am going to create one object and one decoration, different type, and connect them, or I am going to create the object, two decorations, and connect them. This is what we had before in the main, in the text-based example. In the main, for the text-based example, we did this, and we did all of them. That is the reason because the text-based print everything. Here, with the graphical interface, what we are doing is, I can do whatever you want. These are some graphical elements, widgets, clicks. Make click here, something is going to happen. Click here, something is going to happen. Click there, something is going to happen, different. And I can create this one, and then this one, or go back to the first one. It just clicks. This guy is going to create some new elements and is going to put them in this guy. How? Well, always. I am doing some elements, but at the end, the only thing that I do is to call a method in the panel to send to the panel whatever I create. One element or one element decorated. When I have it, I pass this as a parameter to the panel. And the panel will do something with that. After I pass that as a parameter, the only thing that I do is to call the panel a method show. Show yourself. I am going to ask the panel to, hey, show, do something. We're going to review the source code for that, but you can imagine that that method is the equivalent to the operation that we reviewed before. is this action that the panel is going to be able to do, and is going to be executed by all the members in the family of decoration. So far, the main with the constructor, the main with the listener doing something according with your option. Something what? Creating objects and connecting those objects. I am using classes that I haven't reviewed yet, but the classes exist, and I know that I can do these connections. I do the connections, create the object, and the only thing that I do is pass whatever I create as a parameter to someone else. Someone else is going to take care of this. Separation of concerns. Okay. Finally, for this class, my main. And the main should be familiar to you. Create an object main, size, visible, and why not? Enable the closing. The same that in any program that you do. And this is the full class main. The only thing that I have there. Should be easy to follow. And the most important thing, I am doing things with classes that we haven't reviewed yet. But I know how those classes are going to behave because I understand that here I am using the decorator. And I know that what is happening there is I am doing decorations. We need to implement the classes that make this happen, work. Main, done. Next, I need the class that is going to be my panel. In particular, you know, we have several different types of panels. Here, just to make the life easier, what I can do is to use this particular kind of panel. What is the difference between that one, JLayer Pane, and JPanel? Well, a very simple one. That one is a panel, a space for you to work with several layers. So instead of having just one space, one canvas, you have this one, but you have another that you can put over, and another over, and another over. You think about having several pages of some kind of transparent material, and you can work in one page or in the page below, and at the end, all of them together are going to go to the screen. And yes, if you're thinking that I am going to use one layer for the person and another layer for the decorator, that is a solution. Again, one solution. I have my class, it's going to be a panel, a particular kind of panel. So if I want to update my class diagram here, instead of JPanel, I can put this GLP, that one. It's still inheritance. What do I need inside? Inside, do you remember? This is the guide that is going to connect with the full decorator pattern. So what I need is a variable from this class. The name for that class was companion, so I need a variable. It's a variable, is global, therefore in the diagram, a diamond, and all the methods here have access. If I have a variable, I need a method to establish a value for the variable. So I need a setter, and as usual, the setter is going to receive a value, and it's going to put that value in my variable. Okay, the panel set companion. Did you notice that this one is this, and this? In the panel, according with the option that you select with the widgets, what the panel is doing is creating a companion, creating an object from the parent class in the decorator. And we know that that object can be the object alone or the object with as many decorations as we want. And the only thing that I am doing is using that one as a parameter for the panel. That one, the one that I create here, is the one that I am sending as a parameter here, and is the one that I am going to establish here as the global variable in the panel. What is going to happen later? Do you remember? We call this method. That is the method that is the operation. And the only thing that is going to happen in the panel when I call the show yourself is going to be, number one, remove all. That is a method that I am inheriting from the panel, What is going to do? Clean the screen. When you call the method remove all in a panel, what you do is to delete everything that the panel has. Delete everything. Why? Because if I am showing you something, a person with some particular decoration, what I want to do is delete that because a new one can be set. Delete everything. Because I delete everything, something that I can do is to establish again my layout. My layout for my panel is use one column, one row. So I could use a grid layout one by one. I want to use the full space. And then who is brain? My variable. My variable from this guy. And what I am doing? Call this method. I am calling a method here. And if you remember that method, it's going to call a method here, and the method down. Call the method in the parent. Automatically, the same method is going to be called in the full family. And that is going to do something. It's going to put elements on the screen. Now, just because I want to put elements on the screen, something that I need to do, and this is the first time that we do that, it is okay to send parameters. In the examples that we reviewed before, this do something was an empty method, nothing there. In this example, we are using graphical user interfaces. In this example, we need both the original element and the decorations to do something on the screen, to draw something. And in order to allow them to draw something for this particular example, what I am going to do is to share with them the possibility of drawing. I am going to send as a parameter this. Who is this? This is the keyword that represents this object. Who is this object? This object is this panel that is inside of the frame in which everything is going to be drawn. I am sharing with this decorator hierarchy the possibility of draw things in the panel by sending as a parameter this, a pointer to the panel. And that's it. I send the order of guys work, and here is the object that you need to work, the space to draw. And at the end, that instruction is from the graphical user interfaces in Java. It's the equivalent to repaint that you use for your previous Pac-Man and games. When you need the screen to be repainted, if you are doing draws, rectangles, circles, colors, you call repaint. If you are modifying a panel, like adding things or removing things from the panel, the instruction is revalidate. So redraw the panel, and the panel could have different elements. Delete everything, revalidate. And in the middle, you can change whatever you want. You are not going to change anything here, but you are sending the order and the tools to someone else, other classes, to do the changes that you want to do. Okay, now we are done with this one. And we just call a method in this one. So finally we are in the yellow ones. In the yellow ones, the first class that we have, the parent of everything. The one that we use to create an object. We create an object here from that class. Well, it's not a class, it's an interface. No problem, we can use it to create the variable. Not to do the instantiation, but we can create the variable. And the only thing that we are doing in that parent is to define the method that every single member of the family, every single yellow box is going to have. The method, they do something. And that method need a parameter. Notice the type of the parameter. Do you remember that the graphical user interfaces in Java, they are decorators? Do you remember that basically what you have is widgets and panels? Obviously, both widgets and panels have childs. Remember the name of the parent of the full hierarchy? The parent of the panels and the parent of the widgets at the top. This guy. I am sure that you can guess. That one. But you only want to send panels. Could you use this name? Yeah, you can use that name. There is no problem. But in the same way that I did before, if I can use this one and this one, why not go for the parent? That makes my solution more generic. Here, same idea. I am going to send a layer panel. I can put layer panel here. Why not? The name of the parent. So later, that solution can work also with a simple normal panel or with any other category of panels, just because polymorphic behavior of the parent at the top. Done. I have this one, and the parent for the hierarchy of decorations. Going down. Now we can think about this one, the easy one, the simple one, the item without decorations. Following the template, a class that is going to implement the interface at the top. And the only thing that that class needs is to override the method. Which method? This method do something with this crazy parameter that is a panel. Following the rules, right? Now, what I do inside is the solution of your problem. What is the problem that you want to solve here? You know what? I want that class to show on the screen only the little guy. Okay. What about you use an image? You can load an image from a file. What about that image is your little guy? So you don't need to draw the guy. You can do it, but another solution is just get the image. And you can put that image in a label. And well, you have the image. Another thing that you need is a text. You can put that text also in the label. So basically this image of the little guy with the hello student, it uses a JLabel with a picture and a text. You can configure them just to look like one is big and the other is small and both are in the center and so on. This is just configuration to make things look nice, but the solution is a label with a picture and the text. And the only thing that I need to do is to add the label. Add the label where? In a panel. In which panel? The one that I receive as a parameter. And if you remember, this parameter comes from the panel that is in the main area above the different buttons. Click here, trigger an order to the panel to draw a companion that I am sending as a parameter. And that companion, this one, is going to ask to execute the method, do something. It's going to send as a parameter the this, that is the full panel. And here we are with this method using this, the panel, to add a new label with the element that we want to show with the graphics. Done. I want you to notice every single class is doing one and only one thing. And the connection between one class and the other is one line. And one line that represents calling a method, or one line that represents having a local variable, a global variable. Easy connection in the picture, easy to follow the source code. That is the goal of this, the goal of the diagrams and the software design. It should be easy to read, easy to follow, for you to understand and for you to explain to others. Anyway, done with that one. The next one, this one. If you remember that one, it used follow the template. Follow the template, we need a class. That class needs to extend, implement whatever, a common parent. In that one, you need a global variable, the amount that you have here. In that one, you need this method add that is going to receive something and copy to the variable, the set or the add method that we reviewed before. And that one needs also to override the common method, need to override the do something with the parameter. That is the template. And the only thing that the method is going to do in this particular class is to call the do something with the parameter in the object that we have as a global variable. This is the one that is going to guarantee that whatever is inside also execute the same order. And you can compare this one with the graphical user interface, with the one that we reviewed in the previous lecture, and this class in particular is used identical, same template. Again, maybe use this parameter is different, this parameter is different, because now we're working with graphics, but everything else, the same. Done. New one. This child. If you think about those two childs, they are going to be, could be, identical to the one that we did before with the original guy. It's a class. The class extends a parent, a common parent, and inside, the only thing that we do, override the do something method. Do something method with the parameter. I am receiving as a parameter a panel in which I can work. I don't care who is the owner of the panel, where that panel comes from. I am going to work, do something in the panel. Whoever sent me the panel is going to be able to notice the results. Calling the super because of the pattern, and everything else, the action that I want to do. And the actions that I want to do, very similar to this one. Load an image, put the image in a label, add a text to the label, configure the label, whatever, and add the label to the panel. So it could happen that I add one label to the screen, only the label with the guy, or it could happen that I add two labels, the label with the guy and the label with the party thing. I do not know. It's depending of the object and the decorations that I define in the main. But whatever the user chooses to do, the structure of classes is able to configure this in several different ways. The other decoration, the one with the helping thing, the same method, calling the super and below the solution to my problem. And the solution, similar to the previous one, a new label with the picture, with the text, configuration for making it look good, and adding to the panel that I receive as a parameter. Decorator pattern, that is the only thing that I need. With this source code, as you notice, very small, one slide per class almost, you can create this problem. Frame, the panel, the widget, the listeners, and the click is going to create all or some, only two or only one configuration in real time. So, questions? It is clear. Silence. Okay, hopefully that is yes. No. Okay, you're ready. Good. So, moving forward, practice for you to prepare for the exam and maybe to practice. It's not an assignment. I am not asking you to submit, but just for you to think about it and maybe challenge yourselves and doing this during the weekend. What if I ask you to do a program like this one? In particular, what if I ask you to do a program similar to your Pac-Man? Do you remember the Pac? In which you could have a class. That class could create random numbers. Just like that, a class able to create random numbers. Previously, I shared with you this class boss and this class source that basically do something similar. So can you create a class that just create random numbers forever? Probably a combination of source and boss. And then can we have this panel just observing those numbers, just checking which are those numbers. I am asking for the implementation of the observer pattern between one class that could be source and another class that could be a panel. Now, if I can observe the numbers, can we draw these numbers on the screen? Like here. Obviously, the rule could be that the numbers, even though they are random, they should be 0 to 400, 0 to 400. Your screen is 400 by 400. So you always know that the numbers can be on the screen, the X and Y. Can you implement this one as the observer pattern between a panel and another class, maybe running with a timer? If you can do this, it's basically the same result that you have from your Pac-Man. It should be something easy. It's one way to practice the observer. Second, what if I asked you to do a version 2? The version 2 is I want to draw something on the screen, and that something is going to be the random number, the value that you just read from source. But also, I would like to draw as a decoration a shadow. And the shadow is this gray box in the previous position. So I am creating random numbers. And for instance, 1010. In this version, we draw the blue rectangle in the position 1010, whatever. In a second version, we draw 1010, and the blue is going to be alone in that coordinate. The next time, if I move to 55, with this version, the only thing that I'm going to have is the blue dot in the 55 coordinate, and I have nothing in 1010. It's just the last value, the new value is the one that is on the screen. In this version, this should be 55, the new value, and the shadow should be in the previous one, 1010. The next time, a new value, the new value is in the new coordinates, the gray box is going to be 55, and so on. I have this shadow, this box that is always in the previous position. And I am calling a decoration just because, well, the original guy is this blue rectangle. And I am going to have something else. And that something else is this gray box. And the gray box is going to be connected with the blue one. It's going to be drawn in the previous position of the blue one. Another version. Can we ask for the original one, the blue? One decoration is going to be the shadow in gray, the last position, the previous position. And can we create a second decoration that is basically all these yellow squares that cover the previous 100 positions? So decoration 1 is a shadow in the position -1, and decoration 2 is 100 yellow boxes in the previous 100 positions. Obviously, if there are less than 100, well, you do not draw anything, right? It's going to start with only 1 yellow, 2 yellows, 3 yellows, and it's going to grow until you have 100. And after that, well, they are going to disappear, the oldest ones. Can you figure out a solution with this? Because here, what I am asking is decorations. I have a graphical user interface, just like before. I have an observer. We have done this example before with observer. And I have a decorator. A decorator, not the same, but similar to the example that we described with all of this. Homework for you, a recommendation for something that you can do to study and be sure that you understand something like this. Feel free to ask any question by email, but I am sure, hopefully, you can solve this problem with your knowledge of the Pacman and your knowledge of patterns. Any question, guys?
Yes, sorry if I missed you saying this. Did you say that solving this problem on the test, it would be just like us drawing out a class diagram for it? Or were we like needing to code that whole thing on the test? Okay,
let me be clear. You are not going to be asked to do in the exam something as complex as this. Because right now, what I am asking you to do is a program. During the exam, I am going to ask you for a few lines. Maybe I am going to ask you for complete the observer. I am going to give you partial source code of the observer and ask you for the lines that are missing.
Okay,
or
that makes sense.
Okay, yeah. Doing this during the exam could be a little bit long. So my goal is you can do it and therefore review all the lines and all the process. But during the exam, you are going to be asked only one small piece. A few lines.
Okay, thank you for the help.
Okay, welcome. So guys, practice with this. Any question, let us know, but it could be useful for your exam. Good? Yes, remember, I am going to talk about your study guide. I am going to talk about showing you some questions next lecture. My goal is that you have the weekend to study. Next lecture, I show you some examples of questions. I show you a summary of topics that could be useful for you to have been reviewed before. But my goal, hopefully, next lecture, you have a lot of questions to ask, just because you try to do this, or just because you review your quizzes, and so on. So do not wait until I give you topics in the next lecture to start preparing for the exam, because you are going to have only a couple of days, and that is not a good idea. So any questions that you could have, send me an email. If I can, I will answer. If not, I promise to include that question in the review. Good. Okay, guys, see you next week. Thank you.